What's up, everybody? This is EchoLynx. Today, we're going over the Intro to LAN Room from TryHackMe, so let's get started. We'll begin with Task 1, Introducing LAN Topologies. LAN topology just means the design of a smaller network. LAN stands for Local Area Network. Think your home, a small office, or a small school. Topology is simply how that network is laid out. Click View Site. The lab walks you through floors in different topologies. First, the ring topology. All devices connect in a loop. If one cable breaks, you can bring down the entire network. That's why you rarely see rings today. Next, the bus topology. Everything hangs off one central line. It's cheap, little cabling, but it struggles with heavy traffic. In the lab, flooding the bus with packets overwhelms it, and the network goes down. Last, the star topology. Each device has its own cable into a central switch or hub. If one device fails, it only affects that device. But if the central switch dies, the whole network is out. It's also more expensive because every device needs a dedicated run. When you finish the activity, you'll get a flag. Copy it, scroll down to the questions, paste it, and submit. Now, what is a switch? A switch connects devices within a network. In the diagram, switches link the devices to each other and to the router. Why use switches? Organization, you can group devices to manage them more easily. Redundancy. If one switch fails, the rest of the network can stay up. What is a router? A router connects networks together and routes traffic between them. At home, you connect to your router, and your traffic travels across paths chosen by routers until it reaches, for example, YouTube's network. Then the response is routed back to you. Routers route traffic and connect networks. Switches connect devices inside a network. You probably don't have switches at home because your network is small. Most people just connect usually over Wi-Fi, directly to the router from their devices. Questions. What does LAN stand for? Local Area Network. What verb describes what routers do? Routing. What device centrally connects multiple devices on the local network and sends data to the right location? A switch. Which topology is cost-effective? Bus topology. Which topology is expensive to set up and maintain? Star topology. Paste the flag, submit, and you're done with Task 1. Next up, Task 2. Primer on subnetting. Subnetting means dividing a network into smaller parts. Picture a small home office with one switch under a single router. The whole network lives under that router, and you can slice it into smaller subnets, like cutting a cake, so each slice is its own smaller network. An IP address isn't random. It has a network portion and a host portion. For our simple example, treat the first 3 octets as the network part and the last octet as the host part. Each octet ranges from 0 to 255. If the network is 192.168.1.x, that last octet numbers the devices. You can split that host space into multiple subnets, trading total host count per subnet for more control and isolation. The subnet mask is similar because it's also made up of 4 parts, and its job is to tell devices which bits of the IP address are used for the network and which bits are used for the device itself, also known as the host. There are 3 main ways an IP address is used in a subnet. First, there's the network address, which marks the start of the network. This address doesn't get assigned to any specific device, but tells everyone in the network, "This is the network I belong to." For example, if you have a device with an IP of 192.168.1.100, that device will be in the network identified by 192.168.1.0. Next, we have the host address. This is the address assigned to a specific device in the network. If you look at the same network, a device like a laptop or a printer might have the address 192.168.1.100. It's just a unique identifier for that device within the network. The default gateway is another crucial part of the network. It's typically a device like a router that helps your data get to other networks, such as the internet. If your device needs to send data to something outside its network, say a website, it sends that data to the default gateway, which knows how to route it. The default gateway is often the first or last usable address in the network, like 192.168.1.1 or 192.168.1.254. In small networks, like in homes, you don't really need subnetting because there's usually only a handful of devices connected at once. But in bigger networks, like in offices or businesses, subnetting becomes important. Subnetting divides the network into smaller parts, making it easier to manage many devices and keep everything running smoothly. The benefits of subnetting are huge. It helps with efficiency, making sure data moves quickly and doesn't get crowded on one big network. It also improves security because you can separate different parts of the network from each other, like keeping your employee network separate from the public Wi-Fi at a cafe. Finally, subnetting gives you control over the network, letting you apply different rules or policies to different parts of the network. For example, imagine a cafe. They might have two networks, one for employees that connects to the cash registers and other internal systems, and another for customers who just want to use the Wi-Fi. Subnetting makes it easy to keep those two networks separate, even though they can still connect to the internet. Questions. Technical term for dividing a network into smaller pieces. Subnetting. How many bits in a subnet mask? 32. Range of a subnet mask octet? 0 to 255. Address that identifies the start of a network? Network address. Address used to identify devices within a network? Host address. Name for the device that sends data to another network? Default gateway. Submit and move on. Task number 3. ARP protocol. A protocol is a shared set of rules so devices understand each other. ARP, the Address Resolution Protocol, is simple. It has two messages. ARP request, who has 192.168.1.10. ARP reply, I have 192.168.1.10. Here's my MAC. Why this matters? Devices use IP addresses and MAC addresses. Think of creating a phone contact. You link a name and a number. ARP links an IP to a MAC address. Once a device gets the reply, it saves the mapping in the ARP cache for later use. Questions. What does ARP stand for? Address Resolution Protocol. Which packet asks the question? Request. What address is a physical identifier on a network? MAC address. What address is a logical identifier? IP address. Submit and you're done with task 3. Task number 4. DHCP protocol. This shows why IPS act like names while MACs are like fingerprints. DHCP stands for Dynamic Host Configuration Protocol. When a device joins a network and doesn't have an IP, it asks for one. The flow is often called DORA. Discover, I'm new. Can I get an IP? Offer, here's an IP you can use. Request, I'll take that one. Acknowledge, ACK. You're good. Here's your lease time. IP addresses change as leases expire and renew. At home, your router usually plays the DHCP server role. Questions. What packet is used by a device to retrieve an IP address? DHCP discover. What packet does a device send after being offered an IP? DHCP request. What's the final confirmation packet? DHCP-ACK. Submit and move on. Task number 5. Continue your learning. OSI Model. Head to the OSI Model room next. There's a walkthrough on my channel.